compared to conventional gas development. Because you have so many wells, 2,000 wells in Bradford County right now. The risk and the actual occurrence of water well contamination is real. Technologies of scale. Scale means be small, it can mean big. In this case, it means big. To coax gas out of shale formations in Pennsylvania, everything has to be scaled up compared to conventional gas development. What do I mean by scaled up? The wells are longer. You're not just going down 1 mile, you're going down 1 mile and out 1.5 miles or 2 miles. That means the drill rigs have to be bigger. That means it takes longer to drill. It means you have to have frac jobs that are 2 orders of magnitude. That's 100 times larger than the frac jobs that were used for conventional well stimulation in Pennsylvania. And that means you have concomitantly a heck of a lot more waste to handle coming back up from the wells that has to be captured, stored, transported, and disposed of. Because you have so many wells per unit area, you have to have more pipelines, and you have to have more compressor stations. So we could talk about all these other larger impacts compared to conventional, but I'm just going to focus on 2 of them for the sake of time tonight. So here's Bradford County again, and now I'm showing you not only each dot representing a pad, but you can see the various pipelines, transmission pipelines. What you don't see on this map are the gathering pipelines. Every gas well has to be connected to a pipeline. It's called a gathering line. That gathering line takes the gas from that well to a compressor station. From the compressor station, the gas is put into a transmission line, taken someplace where it's taken to market in the near future, offshore. So let's talk about pipelines for a minute. This is a video I took in West Virginia earlier this year. To build a pipeline, you have to clear an area. Next rhetorical question. How many trees were removed just from that slope? 1, 10, 100, or 1,000?
1,000.
Okay. What is a tree? Define a tree. A carbon sequestration unit. This is called burning your candle at all 3 ends. You're building a pipeline to produce more and transport more fossil fuels, which increases carbon dioxide in the atmosphere. You're killing 1,000 trees for every 1,000 feet of pipeline, and those were going to be taking the carbon dioxide out of the atmosphere. And did you notice the fires? What are they doing with all that beautiful hardwood on the slopes of West Virginia? Is it going to somebody's house out in the hollow to help them heat their homes and dethaw their plastic water buffalo during the winter? No, they burn them. Pour kerosene on them, start fires, big bonfire. Terrible thing to do to a tree, isn't it? Compressor stations. This is data gathered by the Post-Gazette in Pittsburgh. It shows before and after. Prior to 2008, how many compressor stations by county? You notice, for example, here's our familiar Bradford County as of, I think this is mid-2014, there were already 34 compressor stations in Bradford County alone. Each one of those compressor stations, as I'll show you in a few minutes, is a large emitter of methane and a large emitter of noise, a nuisance. Here's a typical modern compressor station. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 compressors. Each compressor is running about 9,000 horsepower. They're noisy. Okay, so that's technology of scale, and that's spatial intensity. You got it? In other words, getting shale gas out of the ground in Pennsylvania isn't like what you saw for the last 100 years. It's only what you saw for the last 7 years. The impacts are larger, the risks are higher, they're tangible, they're quantifiable. So let's quantify one of them. Let's just talk about contamination of water wells. Second part of my talk. I call it a local problem because if your water well is out behind your house, it's local. You want that water well, it's absolutely fundamental. to your well-being, the enjoyment of your property, and its value. And if you lose it, you lose all three of those. So another myth perpetrated by the industry. I use those words without caution. We hear about it on TV commercials all the time. Our wells don't leak. They're modern gas wells. They have 4 layers of steel casing, layers of cement. Each one of those is protecting underground sources of drinking water. It's impossible for you to have your private water well contaminated by nearby gas drilling. And I'm going to show you through data collected by the industry and collected by your PADEP that that's a lie. That leaking wells is a chronic problem. It has always happened since they started casing and cementing wells 100 years ago. It's ubiquitous. It doesn't just happen in Pennsylvania. It happens wherever there are cased and cemented wells. And it's a problem that can't be fixed by regulation. So I'll try to prove those points to you in the next few minutes. So what is a leaking well? What does a leaking gas well look like? I'm going to show you one. This one happens to be perhaps the most famous gas well, actually the most famous hydrocarbon well ever drilled in the state of Pennsylvania. I said there have been over 500,000 oil and gas wells in Pennsylvania. I assert that this is the most famous one. Guessford 3, Dimmock, Pennsylvania. For those of you who haven't seen this video before, I'm surprised. But for those of you who haven't, this is the production casing. This is the innermost layer of steel pipe that is supposed to be transporting Marcellus gas from under Dimmock, Pennsylvania, to a pipeline at the surface. If you were to follow that steel pipe down, you would come in first, you would encounter the conductor casing, about 2 feet diameter. You go down about 50 feet to 100 feet, you encounter the surface casing, and then you go down maybe 1,000 feet, and you encounter only that casing. And if this well is doing its intended function, which is producing gas, the gas should only be coming up inside that pipe. But as you're going to see, in this case, it's coming up outside the pipe, as well as inside the pipe. That's a leaking well. By industry definition, that well is not leaking. Let me repeat that. By industry definition, that well is not leaking. Because you can't prove that that gas is polymethane. It's bubbling to the surface outside the production casing, has encountered the aquifer. And that's true. You can't prove that it's encountered the aquifer. It's possible that it has. It's also possible that it has not. But the industry does not count leaking wells, wells leaking methane into the atmosphere as leaking. Let me repeat that. The industry does not count wells that are leaking methane into the atmosphere as leaking. The well is only leaking if it can be proven that it is contaminating an underground source of drinking water. Okay? That's their way of looking at things, not my way. But what you saw is called bubbling in the cellar. We have these quaint phrases that have developed over the years, bubbling in the cellar. If an inspector goes to look at a well in Pennsylvania and doesn't see any bubbling in the cellar, that doesn't mean the well isn't leaking. It just means it's not leaking to the surface. It doesn't mean there isn't methane migration underground from somewhere in that well to an underground source of drinking water or a surface source of drinking water like the Susquehanna River. So absence of evidence of bubbling is not evidence of absence of leaking. And what you saw there could be the result of one or more failed casings or one or more failed cement jobs. And so now we got to talk about casing and cement. And the most important question we have to ask is how often should we expect, after more than 4.5 million oil and gas wells drilled in the last 100 years around the world, what percentage of wells should we expect to be leaking? Using my definition of leaking, either leaking into an underground source of drinking water and or leaking into the atmosphere. What percentage of wells would we expect to have that occurring? So industry data. First I'll show you data from offshore wells, Gulf of Mexico. This is the age of the wells that were investigated, and this is the percentage of wells that are leaking. Industry data. And you'll notice that brand new wells were leaking at the rate of about 5%. 1 in 20 were leaking immediately. and as the wells age, the leak rate goes up. We should expect that. For those of you, let's see, there are a few people in here over 39. Anybody feeling a little awkward structurally nowadays? Yeah, okay, so we all sort of decay over time, so do wells. This is other industry data. This is from around the world, aggregated by decade. And again, same phenomenon, young wells leaking in the 0 to 5, 6, 7% range, and as the wells age, the leak rate goes up. So when I first started citing the industry data on this issue, I was loudly criticized. I get loudly criticized for everything I do. I'm not talking about my wife at this point. Who got that? I'm surprised. I was loudly criticized because I wasn't pointing to shale gas wells. I wasn't pointing to shale gas wells drilled in a regulatorily progressive state with the toughest regulations in the country, where shale gas well failure was an unheard of phenomenon. It doesn't happen. I was pointing to old data offshore Gulf of Mexico, around the world. So we decided 3 years ago to do a study of wells in Pennsylvania. It's a regulatorily progressive state. It went from having no regulations for shale gas development when it started in 2007 to now having its second revision of its Chapter 78 oil and gas regulations, specifically because of the roughly 9,000 shale gas wells that you've had drilled in Pennsylvania. So we decided, let's look at Pennsylvania's experience and let's compare it to what I just showed you. Remember, what I showed you is that young wells within the first 4, 5, 6 years leak at the rate of about 5%, and as the wells age, the leak rate goes up. Let's see if that pattern holds true in Pennsylvania. Because when we started this study, which was in 2013, early 2013, we went into the database of the Pennsylvania DEP and found that in the previous 12 years, there had been roughly 41,000 oil and gas wells drilled in Pennsylvania. Clearly not all shale gas wells. There were only about 6,000 shale gas wells by that time. But 41,000 oil and gas wells. So we decided to study all of them. And to study them means to look at the inspection records. It's the only way the public can know. You're the public, I'm the public. We can go to the Pennsylvania Department of Environmental Protection online database and query it and ask for the inspection records for wells. We did. And we did two things with the data that we found. One was looking backwards. It's called retrospective analysis. What can we determine from the history of these 41,000 wells? How many of them are leaking? What percentage is leaking? Is the same percentage leaking conventional and unconventional? Is the same percentage leaking in Greene County as in Bradford County? Are wells that were drilled after the first set of regulations were modified, after the first modification to the regulations, any better than the wells that were drilled before the modification of regulations? All kinds of neat science questions could be asked. The second thing we did is, okay, let's forecast. It's like weather forecasting, right? What's going to happen in the future? We now have a large database, 41,000 wells, 75,000 inspection reports. We should be able to prognosticate and predict, here is what we should see in the future, given that this is the past. So I'm going to tell you what we found. It was published in a peer-reviewed journal last summer. So first, looking backwards. That's forwards. Retrospective data. I know you're not interested in looking at tables, so I'll point things out to you. What we found out is that when we looked at the conventional wells, about 1% of them, statewide, were found to be leaking. Statewide, about 6% of them, of the unconventional shale gas wells, were found to be leaking. So shale gas wells, which are more modern, they were only drilled post-2007. The conventional wells have been drilled as much as 7 years before that. The shale gas wells are younger, they're leaking at a higher rate.